Hello students, so in this lecture we will talk about viscosity. Now viscosity is defined as the internal friction, uh, internal friction by virtue of which a liquid opposes the relative motion between its different layer. Now what is this internal friction, and first of all what is this relative motion, and what are these different layers that we are talking about? So first, we'll consider that when a liquid flows steadily over a fixed horizontal surface, suppose you have a fixed horizontal surface and the liquid is flowing steadily over it. Now, what you will see that the layer, if we assume that this horizontal layer is not moving, that is, it is fixed and it is moving steadily, and so the velocity of each layer will increase as we move from the horizontal surface. That means what it means is the velocity at this point just above this layer is say v, and if you consider a layer just above this first layer, then the velocity will be increased, say v2. So we call it as v1, it's v2, and let's v3. So v3 velocity is greater than v2 is greater than v1. So we have a difference in velocity. So this difference in velocity gives rise to an internal friction that we initially mentioned, and as a faster layer tends to accelerate the slower layers once and vice versa, right? As the faster layer will try to accelerate the slower layer, and vice versa. The slower will try to make the faster slower, while the faster will try to make the slower faster. So this causes the friction, and this is the friction that leads to what is called as the viscosity of the fluid. Now there is something called a coefficient of viscosity. Now, the coefficient of viscosity is defined as eta. Now, how do we find the expression for eta? If we assume that if F represents the tangential stress between two layers of the liquid, the tangential stress between layers which are moving relative to each other, then according to Newton's viscous resistance, F is proportional to the velocity gradient dv by dx, and the proportionality constant is actually eta. So you can write F is equal to eta dv by dx, and that's how we are getting this coefficient of viscosity. So if eta is equal to 1, or let's say no, not is equal to 1, if this dv by dx is equal to 1, then F is equal to eta. Thus, the coefficient of viscosity of a fluid, you can call it as the tangential stress per unit velocity gradient. Tangential stress per unit velocity gradient. So that's how we can also define the coefficient of viscosity. Now what about the dimensions of eta? So we can write eta as equal to F divided by dV by dx, and it is a stress, so you can call it as force per unit area divided by dV by dx. So if you write the in terms of MLT, so force per unit area is mass into acceleration divided by L square into velocity divided by distance. So that comes around to be equal to m L minus 1 t to the power minus 1. So the CGS unit of viscosity is known as poise. After the name of the Poiseuille. So if we see that the coefficient of viscosity is 1 poise, it means that a force of 1 dyne is required to maintain a velocity difference of 1 centimeter per second. It implies a force of 1 dyne is required to maintain a velocity difference of 1 centimeter per second.